Now we want to discuss JEE Advanced paper. First we are going to see paper 1. In this, first section contain 8 numerical value based questions. Here you want to put the answer up to 2 decimals. Let me read the question. First question says, 2 mole mercury vapor is combusted in a fixed bomb calorimeter with excess of oxygen at 298 Kelvin and 1 atmospheric pressure to mercuric oxide solid. During the reaction, temperature increases from 298 Kelvin into 312.8 Kelvin. If heat capacity of bomb calorimeter and enthalpy formation of mercury vapor are 20 kJ per Kelvin and 61.32 kJ per mole at 298 Kelvin respectively, the calculated standard molar enthalpy formation of mercuric oxide solid at 298 Kelvin is X kJ per mole. We want to find out the magnitude of X. What are the given information? They say 2 mole mercury vapor is burned in bomb calorimeter with excess of oxygen at 298 Kelvin. So that the bomb calorimeter possesses the rise in temperature 14.8 Kelvin. Am I right? And what about the heat capacity? The heat capacity is 20 kJ per Kelvin. That means for 1 degree rise in temperature, 20 kJ should be produced. What is the rise in temperature during the experiment? During the experiment, rise in temperature is found to be 14.8 Kelvin. Am I right? 14.8 Kelvin will be the rise in temperature. So what will be the heat produced during the process? During the process, the heat produced will be equal to 14.8 into 20. That means 148 into 2. Am I right? So that 296 kilojoule heat is produced. That means the process is exothermic, So the value of delta U, bomb calorimeter is used for determining delta U. So delta U of the process, what is the process given here? 2Hg plus O2 gives 2HgO. And during the process, delta U is determined to be what? 296 kilojoule. You will get 296 kilojoule liberated. So you should put negative sign. And please don't forget, mercury in the standard form is liquid. But in the given question, mercury vapor is burned. Mercury vapor is burned to give mercuric oxide solid. So what will be delta N of that process? The product side there is no gas. So 0 minus reactant gas, there are 3 gases, 2Hg and 1O2. So 0 minus 3, delta N is minus 3. So what will be delta H during the process? Delta H equal to delta U plus delta Ng RT. So delta U here is minus 296 kilojoule plus delta Ng is minus 3. The value of R can be taken as 8.3. Even though it is 8.314, they say R can be taken as 8.3. Into what will be temperature here? The temperature is 298 Kelvin. Please don't forget, this term is given in kilojoule. So in order to get this part in kilojoule, you want to put 8.3 into 10 to the power of minus 3. So you can put here as 10 to the power of minus 3. So you can see minus 296 kilojoule plus minus, if you multiply all these things, you can see that you will get it as minus 7.42. So 296 plus 7.42, that will be 2, 4, 13. You are getting 303.42. Minus 303.42 is the delta H during the process. But what is required? You want to determine standard molar enthalpy formation of mercury oxide solid. What do you mean by standard? The reactant should be in the standard state. What will be the standard state of mercury? Mercury in the standard state is liquid. When mercury liquid is burned to get mercuric oxide solid, 1 mole mercuric oxide solid, what is the delta H? Before that, what you obtained already here, you got during the formation of 2 mole mercuric oxide solid, delta H is obtained here. And what will be the delta H during 1 mole production? That is mercury plus half O2. Mercury plus half O2 gives mercuric oxide solid. If you consider what will be delta H, no doubt it will be half of 303.42. That means what? 151.71. Am I right? So minus 151.71 will be the enthalpy during this process. This process means mercury vapor burned to produce mercuric oxide solid. The delta H is minus 151.71. And again they say the enthalpy formation of mercury vapor. That means liquid mercury when converted into mercury gas, the enthalpy change involved is 61.32 kilojoule. That means liquid mercury, the mercury liquid converted into mercury gas. What will be the delta H given? The delta H given is 61.32 kilojoule. This value is given as 61.32 kilojoule. What is want to determine? You want to determine mercury liquid converted into mercuric oxide solid. You want to find out the delta H during this process. You know the Hess's law. Hess's law says enthalpy change during the single step. If you want to find out the enthalpy change during the single step, you can add the enthalpy change in the intervening steps. So enthalpy change of 61.32 plus negative 151.71 should give you enthalpy change during the single step. That is what you want to find out. Clear? You want to find out mercury liquid converted into mercuric oxide solid. Clear? So for that, in order to determine this value, you can add these two values. Adding the two, that is 61.32 plus minus 151.71. The bigger one is 51.71 minus 61.32. On subtracting, you can see 9 plus 2, 11, 4, and you can see what? That will be 3 here, and what about here? Here it will be 0, 90.39. Minus 90.39 is the enthalpy change during the process. What is asked to determine? You want to determine magnitude of delta X. So magnitude of delta X is 90.39. You want to report that answer for 2 decimals as 90.39. Now we can go to the second question. The reduction potential permanganate bar Mn couple is to be determined. What are the various data given? Permanganate to MnO2 electrode potential is given. MnO2 to Mn2 plus electrode potential is given. Mn2 plus to Mn electrode potential is also given. What is required is the electrode potential value of permanganate to Mn. And you know the electron transfer involved in this case is 7, because oxidation state of manganese in permanganate is plus 7 and that in manganese is 0. You want to determine the E0 value of this process. Various electrode potential given are permanganate to MnO2 coupled, and here the electrode potential is given as 1.68 volt. And again you know plus 7 transformed to plus 4, the electron transfer here is 3. And again they say MnO2 converted into Mn2 plus, the electron transfer here is 2 and the electrode potential is given as 1.21 volt. And Mn2 plus converted into Mn, again electron transfer is 2 and the electrode potential given is negative 1.03 volt. What is required to find out is permanganate converted into Mn, what will be the E0 value of it? Since electrode potential is an intensive property, you cannot directly add this electrode potential to get the required electrode potential. Instead, you want to convert it into a delta G value, because delta G is an extensive property. So, first let me find out delta G value of that process. Delta G of permanganate to MnO2. How will you find out delta G? We have the result delta G naught equal to minus NF E naught. So minus 3 into F into 1.68 will be the delta G naught of the first transformation. What about the second one? Minus 2 into F into 1.21 volt. What about the third one? Minus 2 into F into minus 1.03, or you can say plus 2.06 F. Am I right? Same way, here also you can multiply 1.68 into 3. 3 8s are 24, 16 3s are 18, plus 2 20, and 5.04 you will get it here. Am I right? Now 5.04 volt for the first one. What about the second one? It is minus 2.42 F. Isn't it? And what about the third one? 2.06 F. Now, what is the delta G naught of the process MnO4 minus to Mn? Here again you know delta G naught equal to minus NF E naught, that is minus N here is 7, F into E naught value you want to find out. You know that delta G of the process, the direct process, should be equal to sum of the delta G value of intervening steps. So equating the sum to the minus 7FE0. How will you write it? That is minus 5.04 F plus minus 2.42 F plus 2.06 F should be equal to minus 7 into F into E0. Clear now? You can throughout cancel by F. If you cancel by F, you can write this as what? This can be equal to minus 5.04 minus 2.42, that is minus 5.04 is added with minus 2.42, you are getting 6, 4 minus 7.46 plus 2.06. 2.06 is added, that means one is positive and other is negative. So you can write it as what? Minus 5.4 volt. So minus 5.4 is equal to minus 7 E0. So what will be E0? E0 equal to minus 5.4 divided by minus 7. Am I right? That is 5.4 divided by 7. How much you will get? 7 7s are 49, you know. Then again what? That will become again 50. 7 7s are 49. So you are getting 0.77 volt as the correct answer. Now let me introduce the third question. A solution is prepared by mixing 0.01 mole of H2CO3, NaHCO3, Na2CO3 and NaOH in 100 ml water. pH of the resulting solution is. Here H2CO3 readily reacts with NaOH, that all of you know. How will you write the reaction between carbonic acid and a strong base NaOH? Clearly first you will get NaHCO3. No further reaction will occur because carbonic acid taken is 0.01 mole and NaOH in the solution is also 0.01. So this will completely reacts to give 0.01 mole carbonic acid. Now the solution contain carbonic acid 0.01 plus 0.01, sodium carbonate 0.01 mole. So then initially you took 0.01 H2CO3, 0.01 NaHCO3, 0.01 Na2CO3, 0.01 mole NaOH. But NaOH will readily react with H2CO3 to produce NaHCO3. So now solution contain 0.02 mole NaHCO3 and 0.01 mole Na2CO3. What does it mean? You are now obtained an acidic buffer because the solution now contain bicarbonate ion and carbonate ion. That means you are getting a conjugate acid-base pair in the solution. All of you know conjugate acid of carbonate is bicarbonate. If a system contain conjugate acid-base pair, you will call it as acidic buffer. Now the system is an acidic buffer. How will you determine the pH of acidic buffer? You know pH of an acidic buffer is pKa plus log salt concentration divided by the acid concentration in it. What is the pKa here? You want to take the Ka value of bicarbonate in this case because you are considering bicarbonate-carbonate pair. So what will be pKa of bicarbonate ion? That means Ka2 of H2CO3. Ka2 of H2CO3 is given as 10.32. So pK value here is 10.32 plus log salt concentration. In fact, salt concentration is nothing but concentration of conjugate base. Concentration of conjugate base here is 0.01 and that of conjugate acid is 0.02. Clear? So you can write pH equal to 10.32 plus log 1 by 2 or 10.32 minus log 2. Log 2 can be taken as 0.3. So 10.32 minus 0.3. You will get 10.02 as the correct answer. Now let me go to the fourth question. Treatment of aqueous solution of 3.74 gram cupric nitrate with excess potassium iodide results in a brown solution along with the formation of a precipitate. Passing H2S gas through this brown solution gives another precipitate X. The amount of X in gram. What is the reaction involved in this question? You are initially taking cupric nitrate solution. All of you know that iodide can reduce cupric ion to cuprous ion. So, potassium iodide will convert cupric ion to cuprous iodide. So, Cu2I2 along with iodine is produced. Clearly, you know that 2 mole cupric nitrate can produce 1 mole cuprous iodide. In order to react 2 mole cupric nitrate, you require 4 mole potassium iodide. Am I right? When iodine solution is passed with H2S, what is expected? You please note that initially formed precipitate is filtered off. So what results in the solution is iodine. Iodine reacts with H2S, you will get hydrogen iodide and elementary sulfur. Clearly, you know that 1 mole I2 can produce 1 mole sulfur. Clear? Now, 2 mole cupric nitrate can quantitatively produce 1 mole I2. 1 mole I2 can quantitatively produce 1 mole sulfur. What is the number of moles of cupric nitrate taken? You know the given mass of the cupric nitrate is 3.74. What will be its molar mass? Copper, the atomic mass is 63. There are 2 nitrate group. 1 nitrate possesses 62. 62 into 2 means 124. So adding you will get 187. 187 is the molar mass of cupric nitrate. So what will be the number of moles you initially take? Initially you are taking 0.02 mole cupric nitrate. That means you will get 0.01 mole sulfur. What is the atomic mass of sulfur? It is 32. So you are getting 0.32 gram sulfur. Now let me introduce the fifth question. Dissolving 1.24 gram white phosphorus in boiling NaOH solution in an inert atmosphere gives a gas Q. The amount of CuSO4 in gram required to completely consume the gas Q is. You know that white phosphorus undergo disproportionation with alkali and you will get poisonous phosphine gas along with NaH2PO2. From elementary phosphorus, that is zero oxidation state, to phosphine means the change in oxidation state is 3. And when it is transformed to NaH2PO2, the change in oxidation state is 1. To balance it, you know, you want to interchange the change in oxidation state. That means when 1 mole phosphine is produced, you will get 3 mole NaH2PO2. That means to undergo 4 phosphine, when 4 phosphorus atom is transformed, you will get 1 phosphine and 3 NaH2PO2. How many moles of white phosphorus is taken? You know that molar mass of P4 is 31 into 4, that is 124. You are taking 1.24 gram here. So 1.24 divided by 124 means you are initially taking 0.01 mole white phosphorus. Clearly you will get 0.01 mole phosphine only, because when 1 mole phosphorus is transformed, you are getting 1 mole phosphine, other phosphorus atom appear in NaH2PO2. Then they say this phosphine gas is treated with copper sulfate, you know that the product will be Cu3P2. And again, equation when balanced, 1 mole phosphine can produce only half mole Cu3P2 based on principle of atom conservation. 1 mole phosphorus can produce only half mole Cu3P2. In order to get half mole Cu3P2, you require 3 by 2 mole CuSO4 based on the principle of atom conservation of copper. Am I right? So 3 by 2 mole CuSO4 is needed to get half mole Cu3P2. That means 3 by 2 into what is the molar mass of copper sulfate? Copper you know 63, sulfate group is 96. On adding you will get 159. So 3 by 2 into 159 gram copper sulfate is needed for 1 mole phosphine. Please don't forget you produced only 0.01 mole phosphine. Before that, for 1 mole phosphine, how many gram of copper sulfate is needed? Let me find out it. That is 159 into 3, that will give you 9 3s are 27, 5 3s are 15, plus 2, 17, and here it will be 477 divided by 2. Am I right? That will be 2, 3 2s are 6, 8 3s are 8 2s are 16, 238.5 gram copper sulfate is needed for 1 mole phosphine. Clear? But don't forget you produced only 0.01 mole phosphine is produced. So for 0.01 mole phosphine you require 2.385 gram copper sulfate. But you want to approximate for 2 decimals. The third digit is 5, but the preceding number is an even number. So you can simply drop the 5. So the final answer is reported as 2.838 gram. So the answer finally obtained is 2.38. Now let me introduce the next question. Consider the following reaction. You know the role of PBr3 or phosphorus and bromine, that will substitute OH group with bromine. So all of you know what will be the major product here. They say on estimation of bromine 1 gram R using Carrier's method, the amount of AgBr produced is. So what is the product R indicate? You know it is bromine is already here and the OH group is substituted with bromine. What about the molar mass of this compound? Let us calculate. Here you can see there are 1, 2, 3, 4, 5, 6, 7 carbon atoms. 7 into 12 means 84. 2 bromine atoms are there. That is 80 into 2, 160. How many hydrogen here? 1, 2, 3, 4. 4 plus 2, 6 hydrogen atom is there. So on adding that, you can see 250 is the molar mass of this compound. You are taking 1 gram of R. And again you know 1 mole, that means if you take 250 gram of R, you will get 2 mole AgBr. Am I right? Because there are 2 bromine present in the species R. So if you take 1 mole of R, you will get 2 mole AgBr. How many moles are taken? You are taking only 1 gram, that means 1 by 250. And before that, what is the molar mass of silver bromide? Silver atomic mass 108, bromine 80, so 188. So 2 into 188 gram AgBr is produced from 250 gram R. So what is the mass produced from 1 gram of the compound? So 2 into 188 divided by 250 is to be determined. I think the question seems to be simple. I hope you got it. So 188 into 2 means 16, 7, and here it will become what? 376. 376 divided by 250. You know 250 means 1000 by 4. So you can write the denominator as 1000 by 4 and take the 4 in the numerator. 6 4s are 24, 7 4s are 28, 30, 3 4s are 12, 15. So you can say 1504 by 1000, that means 1.504. Again, here you want to report the answer up to 2 decimal. So you can write it as 1.50. So the final answer is 1.50 here. Now let me go to the 7th question. The weight percentage of hydrogen in Q formed in the following reaction sequence is. You want to find out percentage of hydrogen in the final product. What is the final product you got? You know, the phenol when treated with the sulfuric acid and followed by treating with the nitric acid, you will get picric acid. Actually, this is the production of picric acid, you know. Phenol should be first sulfonated, then it is treated with the nitric acid. What is the percentage of hydrogen in the picric acid? Here you know that there are 3 hydrogen, 1, 2 and 3 hydrogen, and you want to find out the molar mass of this compound. What about the molar mass? There are 3 NO2 group. One NO2 group means 14 plus 32, that means 46. There are 3 such group, that means 128. 138 will be the mass of NO2 group. So 138 plus how many carbon here? 1, 2, 3, 4, 5, 6 carbon. 6 12 72. And how many hydrogen here? Here there are 3 hydrogen atom and again there is 1 oxygen atom. Adding all this, you will get the molar mass of picric acid. What will be that? It will be about 229. Am I right? You can add this. You can see that 229 will be the molar mass of picric acid. Out of 229, what is the mass of hydrogen present? The hydrogen present is only 3. So what will be the percentage of hydrogen in it? 3 by 229 into 100. 300 by 229 will be the answer. What about 300 by 229? You can see one time taking it, you will get what? It is around 1.31. You can see it is about 1.31. That will be your answer. Now let me go to the next question. If the reaction sequence given below is carried out with 15 mole acetylene, the amount of the product D formed in gram is. The sequence is acetylene passed through red hot iron tube. You know the product should be benzene. Then it is subjected to Friedel-Crafts alkylation. You will get alkylated benzene. And the alkylated benzene, no doubt it should be cumene. This is subjected to atmospheric oxidation followed by acid hydrolysis, result phenol and acetone. When this phenol is treated with ethanoyl chloride, you will get phenyl ethanoate. No doubt the final product here is phenyl ethanoate. Now, let me find out the mass of phenyl ethanoate finally obtained. You are initially taking 15 mole acetylene. All of you know that 3 mole acetylene undergo trimerization giving 1 mole benzene. If so, if you take 15 mole, actually you are expecting 5 mole benzene. But they say 80% of the product is obtained. So 5 into 80% means 4 mole benzene is obtained. Then this benzene is subjected to Friedel-Crafts alkylation. One may wonder that how you got cumene here. Because you know the initially produced carbocation is primary carbocation. This primary carbocation will undergo rearrangement to give secondary carbocation that will go and attack the benzene ring. As a result, the major product obtained will be cumene. And they say 50% yield is there. You got 4 mole benzene. The 50% of it means 2 mole cumene is produced now. And it is undergo atmospheric oxidation followed by acid hydrolysis. You will get phenol. Actually, this is the commercial production of phenol, you know. And they say the percentage yield of phenol is only 50%. That means only 1 mole phenol is obtained. The expected amount is 2 mole, but only 1 mole phenol is actually produced. And the 100% yield is obtained during acetylation. When phenol is treated with ethanoyl chloride, you will get what? You will get phenyl ethanoate. What is the molar mass of phenyl ethanoate? Please don't forget finally you are getting 1 mole phenyl ethanoate. Clear? Because the entire phenol can be acylated, so that you will get 1 mole phenyl ethanoate. You want to find out the final mass, amount of D produced is to be determined. What is the molar mass of phenyl ethanoate? You know, in phenyl ethanoate, the benzene ring is there. In benzene ring, you know, benzene, the molar mass is what? 78. So, phenyl group, it should be what? 77. And there is CO2 species, that means 44. Then there is CH3, that means 15. Adding all these things, 77 plus 44 plus 15, you will get what? 9 plus 7, 16 here, and 136, that is obtained as its molar mass. That will be our answer. Here you please note that the answer is exactly 136. So 136.00 can be our answer.